All right, random samples. So a simple random sample is the easiest one conceptually. It's generally the hardest one to actually do because, I mean, it says right there, each member of the population is equally likely to be selected. If that's the case, that means that each member of the population has to be available. So it depends on the size of the population. Talking about populations of humans, I have to put all the names of each human in a hat and then select however many I want at random. That's not going to happen. All right. Now, if I have a smaller population, like if I'm doing a random selection of individuals in this classroom and my population is students in this class, completely reasonable. You can take all your names, throw them in a hat, and then randomly select. All right. So that depends. But obviously, that can't be the only way to incorporate randomization into a study, because then it would it would not be practical. It would not be something that people could do. Statistics wouldn't exist. All right, maybe that's what we want. I don't know. Blocking. So this is going to kind of build us to an idea. We call blocking when we group a subjects or any group of individuals. I don't know why I say subjects there. Group of individuals that are similar. That's a legacy typo. Been there since the beginning. Yeah, it's a group of individuals. It doesn't necessarily have to be humans as part of a experiment. It could be any individual, right? Any commonality, right? So you could go into a store, a clothing store, and you will see natural blocking. And go to a clothing rack, not the clearance section because that's not blocking. But you go to like the regular, like everything is not on sale stuff, like clothing grouped by similarity. The same type of sweater is here, the same type of pants is there. And then within that, they're organized by size, right? A subset of blocking, so you got blocking within blocking, all right? Now, if I were randomly to select from those blocks, then I would have something called a randomized block design. All right, that can play out a few different ways. So if I'm using the clothing store analogy, what I might do is go through and randomly select a size. So if I were to do that, I might select at random a particular size, maybe medium comes up. Then I would go through and take all the mediums from each cluster, from each group, and then do whatever I'm going to do statistically to that. I don't know, thread count. I don't know enough about clothing. That's why I wear the same stuff over and over again. So I could, if I wanted to, select an entire block. So maybe I only want the sweaters, or maybe I randomly selected pants or something like that, or skirts. And in which case, I would just take all sizes of that particular group. All right, so just a general kind of statement here. You have population broken up into different groups, and then you're going to break up each group into, if it's an experiment, a control group and an experimental group, and then do a comparison. But you're doing it within each individual group. All right. So, but that's only if it's an experiment. Now, if you're just dealing with clothing, I would have some natural subgroups. I have my population of clothing. I could have shirts, pants, sweaters, and skirts, or whatever. And then my natural subgroups would be the different sizes. And then I could do some comparisons of prices and things like that. All right. Now, a stratified random sample is very similar because you break up your population into different groups. They call them strata. So for the multiple groups, each individual strata is a stratum. So, but it basically means the same thing as a group. But it justifies us calling it a stratified random sample. Now, if I were to randomly select a subgroup from each stratum, so it would have to be at random. So I break up my clothing store into the different categories and then randomly select from within each group, then put those groups, those random selections together and make one big group. that would be a stratified random sample. All right, so there's no preconceived notion as to what's coming out of each individual group. It's selected completely at random. So what I would do, so I have a rack of pants, for example. I give each pair of pants a number, and then throw all the numbers in a hat, and then randomly select out like 5 numbers. And then pull the pairs of pants related to those 5 numbers. Those would go in my sample. Then I'd move on to the sweaters and do the same thing. Then the t-shirts, do the same thing. Right? And then once I have all that stuff together, I would have my mega sample that's made up of the different categories. All right, I'm using clothing, but you can hopefully see how that would generate a representative sample if you're involving people, right? Because we have natural subgroupings of people. You know, you have a population, and then you could break up the population based off of, you could go gender, you can go age groups, you can go race, you can go religion, you can go hair color, you know, any number of different possibilities. Then once you've broken the individuals up into different groups, in high school it's easy because I could go freshmen, sophomore, junior, seniors. Here it's a little bit of a different story because they say freshmen and sophomores, but what does that mean? You know, like it doesn't quite work the same way, because I mean you could be here for 5 years and still only have like 12 credits because you're doing, you know, a course a semester, you know, or you could be, you know, on your second semester here and working on your 50th credit because you're really loading up, you know, you don't have a full-time job. So it doesn't work out quite as naturally there, but age groups could work, you know, majors could work, you know, are you liberal arts or you're something else, you know. But then we would do a random selection from within each natural category. All right, the systematic sample, I mean, it seems kind of weird, but it says obtained by selecting every kth individual from the population. I mean, if you could line an entire population up, then what this would be is like, okay, I'm going to take every 4th person. All right, 1, 2, 3, you're out. 4, you're in. 5, 6, 7, you're out. 8, you're in, and so on. Right? That's not practical in all cases. But if you have a list of student numbers, you know, like you work in the registrar's office and you have a list of all student numbers, and they're in an Excel spreadsheet, organized in ascending order, then you could actually do that, right? So you just, every 4th value, every 3rd value. Where do I get that number from? That number has to be selected at random. All right. Now, we learned 2 techniques. One we already learned. One we're in the process of learning for selecting things at random. We know enough to know that random does not mean 7. How'd you get that number? I picked it at random. Oh, no, you didn't. You just chose a number. Why did you choose 7? I don't know. It just came to my mind. Like by magic? Well, something caused that 7 to come to your mind. Now, it may not be something that you can articulate, but there was some thought that manifested into the number 7. All right? The calculator does not manifest thoughts. So, if I needed to choose a number, I mean, I would have to have some constraints, but like from 0 to 99 or 1 to 100, math, probability, random integer, 0 to 99. Every 94th value would be the number that I would choose in my systematic sample. Now, if I only have 100 people, that could be a problem. Okay? So what you would want first is to determine how many people you want in your sample. No. Whatever. I'm just shocked. Where'd you come from? Mm. Payne's an old friend. Movie reference? So, well, that's the part where you tell me to move.
Obviously, no one chatted that.
I like to give people time to think. Nah.
Wait, what was it say?
Payne's an old friend. Give a couple minutes. Some people like to Google it too and pretend that they know the answer themselves. So, anyway, if I have only 100 people, 94 would be problematic if that's the case individual, because then that would mean I only have one person in my sample. All right. So what I would need is to know how many people are in my population and how many people are in my sample. Divide those two numbers, and that'll tell me how often I want to actually make a selection. All right. So that would kind of limit my random field.
That's the thing. I don't know why it's like circling around you.
I impressed my son once because I was like, you know what, I'm so tough that when bees sting me, they die. He's like, you're the coolest guy ever. Because they just die. And it's only because I'm so powerful. Now it's going to be so cold.
Well, better than having a bee circle all around.
Debatable. I'm wearing a t-shirt. No, it's just disoriented. Still better than the time a bird flew into the class. I think he's cooperating though, kind of.
He doesn't want to be in the middle.
Yeah, well, I heard a squeaking in the classroom once, and I was like, oh, that's ordinary. And one of those vents in the back, it wasn't this room though, so don't freak out. But like one of those vents there, saw like something emerging from it. I'm like, all right, okay, I guess there's a rat coming in. It's disgusting.
Did it end up being a bat?
No, just a bird.
Oh.
Yeah, it just kind of made its way through and then immediately started flying around. But fortunately, there was a student that is familiar with bird keeping. So she cooed at it and carefully took it and escorted it from the premises.
Don't kill it.
No.
Yeah, just smother it.
Cow.
Auf Wiedersehen. Yeah, I didn't see it fly away. So.
I saw it.
Oh, you did? Okay. There was a bee in the classroom for anybody that's confused. All right, yeah, so cluster sampling obtained by selecting all individuals within a randomly selected collection or group of individuals. So going back to the previous page, when you break up your population into different groups, group 1, 2, 3, 4, stratum 1, 2, 3, and 4, that a cluster sample would be the idea that you're going to just select an entire group. And the reason why you would do that, as opposed to randomly selecting from within a group, is because there would be no noticeable or distinguishable difference between the groups, where it wouldn't really matter which group you select, right? And so why not just choose a smaller group? If each group is in and of itself representative of the population, then you're good to go. Sometimes you just want to compare two subgroups to each other. So if you break up a high school population into the different classes, maybe you just want to compare attendance between juniors and seniors. You know, that could just be the only groups that you care about, in which case you take the cluster of juniors and the cluster of seniors and compare those two. right? So the short answer for a lot of this is it all depends. Convenient sampling, sample in which the individuals are easily obtained. There's nothing more to it than that. There's no positive or negative to that. Convenience could be good or bad. Depends on how the individuals were obtained. Just because something is easily obtained doesn't mean you did anything wrong. But if you got your data very easily, you just want to make sure you did it the right way. All right. So if your convenience sample is a voluntary response sample, or if it's related to anecdotal evidence, that's a problem. But if it was just, hey, you happen to be in the right place at the right time, you know somebody, like you needed information about the population at the college, and you just happen to know the registrar, and they were able to give you the data, well, that's really convenient. Good for you. Nothing wrong with that, right? But if you're trying to draw conclusions about the entire college, and the only way that you're going to draw that conclusion is by polling the individuals in this class, it could work. You just need to somehow guarantee that the individuals in this class are representative of the population as a whole. All right? So if you can make a case for that, it's fine. So you would want to think ages. You would want to think majors. Race, possibly. I mean, I don't know necessarily, but stage of life, because age and stage of life don't always correspond to one another. But we have individuals who are working, we have individuals who are not, but generally if you're in a stat class on a Saturday morning, it's usually because you have something else that you need to be doing during the week. So there's generally a case for that. But those are some possibilities that come into play. Motivation. Time of day and motivation usually go hand in hand, I've noticed. That's anecdotal. I haven't proved it, but I have a long history of experience, and I do know that on a Saturday morning, you're more likely to find some motivated students than you do on a Tuesday morning. So the full-time 13th graders, hit or miss. Saturday morning, especially this time of year when I'm seeing the same faces week after week, that is the definition of motivation, right? So, is that representative? Okay, so you're all motivated. Is that representative of the entire population of the college? I would imagine not necessarily. All right, but I have no evidence of that. Matched pairs. This is a fun one, I think. One sample is drawn and 2 measurements are taken, most usually before and after. All right, you see evidence of this on TV commercials all the time. It's the hair growth, weight loss commercials. Like the picture of the guy before the hair growth formula, and the picture of somebody who's completely different afterwards, but it's supposed to be the same person. Or actually, that's more consistent with the weight loss ones, where it's like you have individual before the program, and then like a bodybuilder afterwards, who is definitely not the same person. It's just that person's face is photoshopped onto the so. But that would be a case of matched pairs before and after. You have the same person, a metric is taken before and after whatever the imposed treatment is. All right. But there's other cases that would be matched pairs as long as it's a single individual, 2 measurements. I had a student do a project on dexterity, left hand, right hand, and the conclusions were that it was inconclusive. And there was a pretty significant lurking variable in there, but not in a terrible way. It was just a way that the student was able to actually kind of learn from the experience, and that was the most important part, I think. So the study was, it's a child's toy, like it's a box. It's got geometric figures in it, and little cutouts on the top of the box, like star shape, heart shape, whatever. And the kid's got to take each figure and put it through the appropriate cutout in order to get it in the box. All right. So the study was, will left hand versus right hand have an impact on the time it would take a person to do that? I thought it was a great study. I didn't even account for the lurking variable. And so it seemed to me like it would be matched pairs, where you'd have a person who would do it with their dominant, we get dominant and non-dominant, because a person could be left-handed doing it with their left hand. It should not be compared to a person who is right-hand doing it with their left hand. You know? So it didn't even occur to me that there was a lurking variable there. So we would have, well, I wasn't involved, except for reading and grading, but the student had individuals conduct a study with their left hand or their non-dominant hand first, go through the process, get the time, and then do it again with their dominant hand. Sounded great. The data was completely skewed because in doing it the first time, they learned from the experience. Because it wasn't like little infants doing it. It was, she had elementary school students doing it and middle school students doing it. They were able to learn from the experience, and naturally, whatever hand they used for the second time around, it was quicker than it would have been had they not had the experience of doing it the first time around, even with the non-dominant. She then switched it up and had them do dominant hand first and then switch over to the non-dominant. Same deal. So it skewed the results completely. What it should have been was two independent samples. One group of individuals just doing it with the dominant hand, and one group of individuals doing it with the non-dominant hand, and then comparing averages from there. But, you know, it was too late at that point. So what seemed like it should have been matched pairs, it seemed like a natural situation where you have one individual and two measurements. The idea that experience with one measurement would impact the other, it threw off the whole study. But it was a good learning experience. Student got an A anyway, because, you know, it's all about the learning experience. And so, so yeah, but anything where it would be a before and after, any situation where you're dealing with two measurements with a single individual, it could be matched pairs. You just got to be careful. All right. I'm just trying to think. If you were to do, I'm just thinking of the car situation, like the miles per gallon, that would not be matched pairs, even though it's the same car, because you're imposing two different treatments. One would be the 87 octane and the other would be 93 octane. Now, if you're dealing with miles per gallon in the car, pre and post, let's say, changing your tires, like you just like one single event, you change from the all-season tires to the winter tires. You collect miles per gallon over a period of time, keeping everything else constant, and then miles per gallon over a period of time, again, keeping everything constant. The only thing that changed in the middle was the fact that you changed your tires. Then that would be matched pairs because it would be the single car with two separate measurements being taken, right? And you're not altering octane. It's the only thing that changed would have been the tires. That would be an example of that. So there's a lot of gray area here, and what I find is that people think something's matched. Basically, they think one thing when it's the other, and that's one of the reasons why I had to do the project proposal, because when you submit and say I think it's matched pairs, they say yeah, it's actually independent samples, so this is how you should go about doing it. We can kind of cut off a lot of the unnecessary failings that might occur. Voluntary response sample. If this happens, just toss out your study immediately. It's all over. Any study that's voluntary response is garbage. Like any. There's no value to it. Not even to get a rudimentary sense of the situation. Like you think, all right, I'll just poll these individuals and it'll give me some meaningful data. It'll be helpful. If it's voluntary, it's out. It doesn't matter. You might think that you're getting meaningful information, but based solely on the fact that individuals are volunteering to respond, it automatically introduces bias. Anytime that there's no randomization involved, there's automatically something fishy involving the study. But anytime people are self-selecting to be part of a study, it's over. Meaningless. All right? And people draw conclusions about voluntary response samples all the time. And folks accept those conclusions all the time. I mean, anytime you go onto a website and you see like one of those polls, and you click on it, like, oh, who do you vote for county executive, whatever, president, doesn't matter. You click on somebody, you hit submit, and then you see the outcomes. It's meaningless. I don't even know what I'm looking at. Like, the only people that even went there are people who first on that website, which means they selected themselves to be part of the article, I suppose, so they have a vested interest. And then they selected themselves to be part of the actual study, the poll, right? Really, the only thing that you can do when you, in terms of getting an evaluation to get a sense of what's going on, the only thing that you can come away with from that is the idea that other like-minded people either think the same or differently than you. So other people who selected themselves to be part of this study either agree or disagree with you. What does that mean? I don't know. I can't imagine that's anything that you could project onto an entire population. You know those course evaluations? The one where you talk about how great or awful your teacher is, that nobody ever looks at. Yeah, I think those are hilarious because, and I didn't think they were hilarious initially because I believed what they said, that they go to the dean of something or other and they read them and they offer constructive criticism. But then when the dean at the time came up to me with a file box, said, hey, these were in a closet. I thought you might want them. And then he handed me the box. I blew and waved off a layer of dust that was like a 1/4 inch thick, and I don't think I'm exaggerating. Opened it up, and this is at the time before it was digital. There were years of course evaluations. The student fills it out, bubble in, teacher's terrible, whatever. Years of them that nobody ever looked at. I was like, oh, okay, cool. And then I started looking through them. I was like, well, he gave them to me. I might as well. And I was like, okay, 30 students, great, awful, okay. Great, awful, okay. There's always like one or two that are like, he's the most terrible teacher ever. Doesn't care about his students. Doesn't like he's mean, everything. I was like, yeah, that's because you didn't do anything and you were failing. Like what's that? Some are. Yeah, no, and I'll tell you, if I got my surveys back and it was like 29 out of 30 that said I was terrible and 1 that said I was good, I would take a long look in the mirror and start wondering what I'm doing wrong. But when it's the other way around, it's like, all right, you just didn't like me. Like, I reminded you of some ex-boyfriend that you hated.
I had this terrible professor that is giving us 10 points to do it, and I was actually going to write an essay on how horrible he is, but I need my 10 points, so I'm just going to put great.
Oh.
That's another thing. Like, they give us praise, so
Yeah, we don't see them until halfway through the following semester.
No, I know, but I feel good that he's giving me the 10 points, I'm just going to put great.
Oh,
It's
yeah.
actually horrible, so, yeah, they don't work. Those.
Yeah, so I offer, because we select one, the senior adjuncts only have to select one course to do it. And so I always select the smallest course that I teach, just because it's less effort. But I have my own survey that I have students fill out at the end of the course, which is more meaningful for me. So I have one of my weekday classes, so my calculus, doing it this semester for the college one. But I'll have you for 5 points, I think. Do the one for me, but you're gonna have to put your name on it. Because otherwise I can't give you the points. Yeah. Well, basically it's just a way for you to say, you can offer constructive criticism. It's just now you just can't be like an internet troll. Like you can't be terrible about it. You can say things like, oh, you can improve in this area. Oh, we would have, maybe more practice on this, whatever. You can offer constructive criticism. You just can't be a jerk about it because you have to put your name on it. That's all I have.
But it's like the school, like you get a lot of bad reviews besides that with your job.
Not that I know of, but I never got a lot of bad reviews. So.
No, like for example, I know all the microbiome teachers here in WCC have by far the worst results in probably in every problem they're that bad, and they still have the job. So I was just wondering.
Yeah, I think.
Like it's just.
I don't think really anything ever comes of that, and the way they advertise it for us is that it's supposed to help us reflect on our teaching, not as a evaluative piece. So, like they don't impact our job status based off of those outcomes, right?
Because I'm looking at part that sciences are very hard to get teachers, so they're not going to really try to get into like those microbiology, physics teachers.
But especially a lot of nursing majors, I've already taken my pre-recs, but microbiome, I was like, it's ridiculous. Like they don't even teach you. They just stand there and just expect you to know things. Like it's ridiculous.
It's something to add to that. And there's no feeling no matter where you go. I took micro 10 years ago at Bronx Community College.
Yeah.
This professor, he knew the stuff. He didn't know how to teach it. And there were so many complaints about him. He was out of Bronx Community. I'm taking it now because it expires every 10 years. Guess who's the professor? That one from Bronx Community College. I'm not kidding. I think so far,
They also, the only one that's 5 years old is Castella's the only one number one. No, she's the only number one. If you have Bronstein, if you have others, you are failing. Don't just say that. I'm just saying because I don't think anybody's gotten an A. And I've gotten an A like all my prereqs, including AP1, Chem 1, Chem 2, like, and this class like makes me cry.
The thing is, so evaluation teachers can be very tricky. Surveys from students definitely. I mean, there's a place for that, but to evaluate somebody's job and livelihood based off of that is kind of tricky because all it takes is one person who just doesn't like somebody. Because like there's often a mob mentality where it's like you have, let's say, 10 people who have legitimate complaints about a teacher, and then you have 30 other people who do no work. And so the 10 people are like, it's unfair, you're not doing the right thing, blah, blah, blah. Then those other 30 people are like, yeah, you're not. You're right. You're definitely not teaching us at all while I'm in the back sleeping. So, so that could be a little tricky. And when it comes to voluntary response, it's very easy to kind of pad the stats. It's like, hey, torch this professor, will you? Like on the survey. So I understand that that's one of the reasons why they avoid that sort of thing. So they're actually starting a new approach where they're getting more administration involved. Senior adjuncts will be observing less senior adjuncts to make sure they're qualified. The issue would be.
Is there an age limit to teach?
That's called discrimination. Yeah, I mean there's a case of like knowing when to hang it up, but then there's also a case of like, I mean, yeah, it's like they just can't, like.
But you didn't come to anything? That's
Generally
weird that
not.
you can
Just go to
put them
ratemyprofessor.com.
upside the college, basically.
Ratemyprofessor.com. So, I know something like this, radio show call-ins. Like I mean, I listen to sports radio often, it's like political radio and things like that. But just focus on something lighter, the sports radio. Like oftentimes, people will walk away with the impression that a coach is bad or a player is terrible just because all they keep hearing is people calling in saying that person's terrible, that person doesn't know what they're doing, and so on. And then that becomes a narrative. And that's only based on self-selection. It's the court of public opinion. So a voluntary response is very dangerous. It's good for, your own social circles to kind of flesh out what your belief system is. But in terms of drawing conclusions en masse for an entire population, it's very dangerous. So we completely and totally stay away from voluntary response. Right. Now, in the case of an actual experiment, defined set of procedures here, very straightforward. Identify the problem, determine the factors that affect the response, determine the sample size. That's something that's particular to a scenario or situation. So you're conducting a study, you would need to determine the sample size. On a test, I would have to tell you the sample size because you can't read my mind, at least not yet. Determine the level of response, nominal, ordinal, interval, or ratio. Collect your sample using randomization and replication. Replication is very important because when you conduct an experiment, you don't just do it once because you could have extreme circumstances occur. All you need in a medical study is somebody to have an allergic reaction, and that's the end of it. You do that one time, and it's like, okay, well, the person had an allergic reaction, and because of that, they stopped breathing. Well, okay, this drug will kill you then. Well, will it? Or did that person just have an extreme reaction? How do we know? Well, we replicate. We try it again with a different group. All right? Now, if there's a substantial reason why that person had that kind of reaction, maybe there's something within the drug, then that's a different story. But if you have no reason to believe that it should cause that reaction, then it could have been some underlying medical condition that the person had. A lot of different possibilities. That's why they say in all of those drug commercials, where it's like, it's going to help you with your allergies, but it might give you suicidal thoughts, it might cause your heart to stop, in less than 1% of the outcomes, it might cause your kidneys to just stop working, like all these different possibilities. That's because when they did their trials, it happened one time. It happened 2 times out of the thousands of people that they were. Right? Apply your treatment. That's only for an experiment because you're not applying any treatment if it's just an observation. And then you test the claim. The testing of the claim is a hypothesis test, and that's down the road. All right. So the experimental design related to Vicodin, which is a pain-relieving medication, if you didn't know. Your experimental units would be students in our class. Well, there's too many. So I'll just say we have some students that we'll call A, B, C, D, and E. All indications is that he's like one of the best teachers ever. Yeah. But he can get loud. But apparently not in the scary, I'm going to kill you sort of way, but in the surveying. So, it does send mixed messages, though. Like, should we be going into a lockdown? Evacuating? Closing the door? Running for cover? It took a while for me to get used to that, but once I did, it's
like, why does we got a priority? What's the point?
I don't know. I haven't been in the class. So.
You find out that they start teaching here, they're being studied and stuff.
Well, all I know is once every like 2 or 3 weeks we get a good laugh out of it, so that's fine with me. So the problem to be solved or the claim to be tested. Problem is Vicodin effective for pain relief? Factors. Well, we'll also have to address the explanatory and response variables, so we'll do that now. But the factors go a long way if you have no idea what the explanatory variables would be, explanatory variable in an experiment, response, then listing the factors can kind of give you a clue as to what they should be. But we'll do that after, because I think it's probably obvious in this case. Amount of Vicodin, amount of pain relief. Effective, how about just amount of pain? Because relief would be the difference before and after, which you could get into, but it would be, I take the pill, what kind of pain am I in? So you can go either way with that. But the factors that would impact this. All right. So what are some factors that would impact the amount of pain that you're in? Cause, right? All right, hangnail or broken leg.
How much pain they're in, how much they weigh. Is it a weight-dependent drug?
So we'll say physiology to account for all that stuff. Yeah.
There's a
Ton of them, yeah. Type of pain. So cause and type of pain possibly going hand in hand, but maybe not. Because you could be in, let's say, a car accident. One person walks away with a broken leg, another person walks away with nerve pain. All right, two different types of pain treated in two different ways, potentially. All right, so, but physiology, you get into a person's weight, their age, their blood pressure, what other kind of medicines they're on, right? So other meds. Yeah, the Vicodin itself. Yeah, one of the factors should be your explanatory variable, right? So the factor that would affect pain, well, in theory, one of them would be whether or not you're taking Vicodin, all right? And specifically the amount, right? Because I use the term amount because if I'm saying 0 Vicodin, I'm looking at a placebo. If I'm saying, I don't know what the dosages are, but I could vary the dosage, maybe give a low dosage versus something a little bit higher, all right? But there's a lot of things that we'd have to take into account here, and we got to be careful about. Because if we don't hold all this other stuff, or at least attempt to hold all this other stuff constant, then they can interfere with our outcome, all right? Sample size. Well, I have my sample. This is my sample. I took my population and I created a sample. And here we are. All right. Determine the level of the response variable. Well, I suppose it would relate to how we measure the response variable. Oh, what's the name of the scale? Yeah, intensity, but what's the name of the scale at the hospital? Yeah, but there's a name for it.
The pain scale?
Yeah.
The Wong Baker scale.
The
Wong Baker.
That's the 1 to 10? All right, but a scale of 1 to 10. Okay, so if we're going with that, and you could define it any way you want. Frowny face to smiley face, or smiley face to frowny face, however you want to do it. But 1 to 10, and then maybe put some frowny and smiley faces along with that. It's up to you. But we have some numbers here. Nominal would be just categorical, where you're just breaking them up into groups where there's really no discernible difference. So that would mean that 1 and 10 are not different from one another, but they are very different. So it's not nominal. Ordinal means that you could put them in some order, but the differences would have no meaning. I think anybody who's at a level 7 would disagree with that if they're being compared to a level 2. So I think we're going into the interval level.
That's the strange thing about panoramic. The person who's feeling the 7 can really
yeah, your 2 and my 7 are different. Yeah, so that's a subjective component. And that's where the placebo comes into play to get the baseline sense of what just taking a pill means for a person. Interval level, because 0 can't be in the set, I think. Because if we're measuring pain, 0 would be no pain. Now, I know the reality of it, but we're gonna assume that things are going the way they should, and that is the only folks that are taking the Vicodin are the ones that are experiencing pain of some kind. All right. So why would I include 0 here? I would not be giving Vicodin to a person who is not experiencing pain. All right. So interval is what would make sense. Now, if I change my response, if I, instead of amount of pain, if I change it to amount of pain relief, that would be a change in pain from before to after. Then 0 would make sense, and it would go to the ratio level. Because 0 would just mean that there's no change. I didn't get any better. All right? It could actually account for some negative numbers, too. Because if I started off with a level of 2 and I ended up with a level 7 afterwards, that means I got worse after taking the pill. Not expected, but it could happen. I mean, I've been in the hospital. It has not been fun, but they're like, okay, we'll give you something for it. And then an hour later, how are you feeling? Right before, my appendix perforated is what they said. How are you feeling? It's getting worse, doc. All right, well, we'll give you something else then. Then that was before they diagnosed it for what it was. All right, so it can happen. They give you something that's supposed to help, and it doesn't help. All right, or makes it worse. Collect your sample using randomization and replication. All right, so that's the fun part. Not fun as in hard, but fun as I think is fun. We'd want to break our group into a control and an experimental group. And we do that by a simple random sample. The control gets a placebo. The experimental group gets the Vicodin. In each case, we're going to measure pain. And this is just a general framework, because there's obviously more to it than this. It's like you don't just hand somebody a pill and then measure pain. You're gonna take blood pressure. You're gonna take temperature. You're gonna do a lot of things. All right. It just gives you a sense, and then we compare. All right. Then you decide: do I want this to be a blind experiment, or do I want people to know if they're taking a placebo or not? I don't want people to know if they're taking a placebo. So I'll blind it. You can double blind it if you don't want the administrator to know either. I don't know that I care in this case, but you might. Personally, I might just blind it just so I don't have to look a person in the face who's in pain and tell them they're not getting a real drug. I'm a human too. Here's something that's not going to help you. Enjoy. Drink a lot of water. Enjoy your Jell-O. So random selection. So I'm going to give each of these values a number. 1, 2, 3, 4, and 5. So we got Abe, Brian, Chris, Dave, and Esther. And I'll just go down the line. And I'll just alternate. Or I can alternate, or there's a lot of possibilities. I can do even numbers. So in one group, I can go odds in another if I want to be systematic. I can just do the first, well, I have a total of 5 people. So roughly half of them are going to go in one group and half in the other. Actually, to make life easier, what I'll do is I'll create a 6th person. I'll get Fred in there. So I'll do a random selection of 3 values. The 3 values that come up, I'll just throw those in the control group, and the other 3 I'll put in the experimental group. There's a lot of ways to do it. This is just the way I'm choosing to do it here. Now, if I get a repeat, I might want to do it again, but we'll see. So 6, 1, and 4. I didn't get a repeat, so 6, 1, and 4. Now these are the lucky or unlucky people, depending on how you look at it. Who's left over? 2, 3, and 5? Now, if it's really an experimental drug, you might have some reservations about this whole thing. Like, I mean, Vicodin's been on the market. We know what this is. In the prescribed doses, it's not going to kill you. Okay? But if it's a real experimental drug, nobody's ever heard of it. I don't know. You're participating in this study. Maybe you want the control. Or you're nervous. Maybe there are some serious side effects that you have to be careful about. That's why you sign a waiver, right? But randomly, I pop these folks into one group and these individuals into the other group, and then we go from there. So then I would get another group of 6 people and do the same thing again. Break them up into 2 groups randomly. Control experiment. Go through the same approach. Get my results, compare. Then once I've gone through all my clinical trials, then I start compiling my information. And then from there, I see if I can make some inferences about the population. But it's only after a sufficient number of trials in this study. All right, so that is page 48.